Alright, so in this video, I'm going to solve the equation 4 to the power of x minus 2 to the power of x is equal to 240. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So I'm going to first start with my equation, 4 to the power of x minus 2 to the power of x is equal to 240. And from here, I'm going to rewrite 4 as 2 squared. So I get 2 squared to the power of x minus 2 to the power of x is equal to 240. Now, I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So in this case, 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x. So I have this minus 2 to the power of x is equal to 240. And now I can rewrite 2 to the power of 2x as 2 to the power of x to the power of 2. So I get 2 to the power of x to the power of 2 minus 2 to the power of x is equal to 240. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y squared minus y is equal to 240. And now I can subtract 240 on both sides. So these two cancel out and I get y squared minus y minus 240 is equal to 0. So what I have here is a quadratic equation. And to find the solutions of this quadratic equation, I can use the quadratic formula. So if you guys already didn't know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, looking over here, a is 1, b is negative 1, and c is negative 240. So I get y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 240 all over 2a, so 2 times 1. And this simplifies to 1 plus or minus the square root of 1 plus 960 over 2. And this turns into y is equal to 1 plus or minus the square root of 961 over 2. So now, the square root of 961 is 31. So I get y equals 1 plus or minus 31 over 2. And now I have two solutions. I have y equals 1 plus 31 over 2, and y equals 1 minus 31 over 2. So my two solutions are 17 and negative 15. Alright, so for this video, I'm going to be solving the equation 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. So I'm going to be solving for x in this equation, as that is the only variable. And now for my solution. I'm going to start by rewriting my equation down here so I have more solving space. So my equation is 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. Now from here, I'm going to be using the property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 8 to the power of x plus 9, and I can rewrite this as 8 to the power of x times 8 to the power of 9. And this is equal to 9 to the power of x plus 8, which I can also rewrite as 9 to the power of x times 9 to the power of 8. Now from here, I'm going to divide both sides by 9 to the power of x. So then for my right hand side, these two cancel out, and I get 8 to the power of x times 8 to the power of 9 over 9 to the power of x is equal to 9 to the power of 8. Now I'm going to divide both sides by 8 to the power of 9. So then these two cancel out, and I get 8 to the power of x over 9 to the power of x is equal to 9 to the power of 8 over 8 to the power of 9. Now, from here, I'm going to take the log on both sides. So I get log of 8 to the power of x over 9 to the power of x is equal to log of 9 to the power of 8 over 8 to the power of 9. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 8 to the power of x over 9 to the power of x is going to equal log of 8 to the power of x minus log of 9 to the power of x. And I can use the same property of log 9 to the power of 8 over 8 to the power of 9 to make it equal to log 9 to the power of 8 minus log 8 to the power of 9. Now, another property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is the same thing as b times log a. In this case, I can use this property for all my terms over here. So to start, log 8 to the power of x, I can move this to the front, and I get x times log 8. Now I have this minus log 9 to the power of x, I can move x to the front, so I get x times log 9. And this is equal to log 9 to the power of 8. I can move 8 to the front, so I get 8 times log 9 minus log 8 to the power of 9. I can move 9 to the front, so I get 9 times log 8. Now, because both of these terms have x in them, I can simply factor out x. So I get x times log 8 minus log 9 is equal to 8 times log 9 minus 9 times log 8. Now, we obviously want to find the value of x, and the only way to do that is to get rid of this log 8 minus log 9 by dividing both sides by log 8 minus log 9. So then these two cancel out, and I get x is equal to 8 times log 9 minus 9 times log 8 over log 8 minus log 9. Now, log of 9, we can simplify this to log of 3 squared. And remember, if I have something in the form log a to the power of b, I can move b to the front. So I can move 2 to the front, and this is going to equal 2 times log 3. Now I can do the same thing for log 8. Log 8 is equal to log of 2 to the power of 3, and I can move 3 to the front, so I get this equal to 3 times log 2. So now from here, I get x is equal to 8 times 2 log 3 minus 9 times 3 log 2. And I have this all over 3 log 2 minus 2 log 3. Now 8 times 2 is 16, so I get x equals 16 times log 3 minus 27 times log 2 over 3 log 2 minus 2 log 3. And all of this is equal to 9.6548.